Hello, in this video we're going to talk about an interesting proof of irrationality of square root of 2. But before we get to that, we're going to talk about a concept called infinite descent. So what is infinite descent? Infinite descent is a particular method of proof by contradiction. So how does that work? Imagine you want to show that an equation does not have any solutions over positive integers. The way you deal with that is you assume there's an integer, and then you assume that certain solution is the smallest solution of that equation, and then you find another solution which is smaller than your given solution, and that leads to a contradiction. So that's the idea of infinite descent. So how do we use that in proving irrationality of square root of 2? First, let's talk about the usual proof of irrationality of square root of 2. This is the proof that is the most famous one and most of you have seen before. So the way it works is you assume that square root of 2 is rational, a over b for positive integers a and b, and then you assume that this fraction is reduced, a and b are relatively prime. Then what we do is we square both sides and we cross multiply. We get 2b squared equals a squared. That means a squared is even, which means a is even. Then we take that a equals 2c, plug it back into the equation. We get 2b squared equals 4c squared. Dividing by 2, we get b squared equals 2c squared, which means b squared is even, therefore b is even. So now we got that a and b are both even, which means GCD of a and b is not 1. And that is a contradiction. Another way of stating this proof would be, instead of assuming that GCD of a and b is 1, assume that a is the smallest integer such that square root of 2 can be written as a over b. Then you find another one, which in this case would be c over d, which is the same as the square root of 2. Now I would like to show you another proof that uses infinite descent, but in a different way, without really using any fact from number theory. And here is the proof. We're going to assume that square root of 2 is equal to a over b, and we're going to choose b to be the smallest positive integer, that square root of 2 is a over b for two positive integers a and b. Now what we do is we're going to subtract 1 from both sides. We get a over b minus 1, take the common denominator, take the reciprocal of both sides. We get 1 over square root of 2 minus 1 equals b over a minus b. If you look at the left side, 1 over square root of 2 minus 1, we can simplify that by multiplying by the conjugate of the denominator. The conjugate of the denominator is square root of 2 plus 1. If we multiply the numerator and denominator by square root of 2 plus 1, we get square root of 2 plus 1 over 2 minus 1, which is 1. So square root of 2 plus 1 is equal to b over a minus b. Subtracting 1 from both sides, we get 2b minus a over a minus b. So notice that we haven't really used any fact from number theory. All we did was a little bit of algebra. Now what I'm going to show is that in fact a minus b is a smaller denominator compared to b. And that fact can be obtained by noticing that square root of 2 is between 1 and 2. Clearing the denominator, we get b is less than a less than 2b, which means a minus b is less than b, and of course it is also positive, which means we were able to write down square root of 2 as a fraction with a smaller denominator, and that is a contradiction. So this is the idea of infinite descent. I will later post some videos on infinite descent and how it is used in solving other types of problems. If you like this video, make sure you subscribe to the channel and like the video. Comment below, let me know what kinds of topics you're interested in, and I will see you in the next video.